Now that we've discussed the final step on how our naive Bayes classifier makes decisions, we should talk about where the probabilities that feed into this decision making actually come from. And this means backing up a bit and talking about statistics. Now, this is the part that no one gets excited about. I've yet to hear somebody say, yes, statistics, my favorite topic. But the thing is, statistics is everything in machine learning, and this project will give us a chance to get some exposure. Alright, so we're interested in calculating the probability that an email is spam. However, it's not like we can simply work out the probability the same way we would work out the probability of, say, flipping heads on a coin flip or rolling a 6 with a die. With coins and dice, working out the probabilities is fairly straightforward, but let's review some of these concepts nonetheless because they're going to come in handy later. Now, with coins, we know that there's two sides, and a flip has a 50-50 chance of showing heads. With this dice here, we know that there are 6 sides, and we've got a 1 in 6, or roughly 17% chance of rolling a 6, or any particular number. Now, let me ask you a question outside of the realm of flipping coins and rolling dice. How would you work out your probability of getting hit by lightning? Yeah, I know, you could probably ask Google and get the answer. But if you had to calculate it yourself, how would you do it? Well, the simplest way to do this is by dividing two numbers. The total number of times people get hit by lightning and the total number of lightning strikes. Now, I trawled through Wikipedia for you, and I've dug out these figures. About 240,000 people are injured by lightning every year. Now, 240,000 actually sounds like quite a lot of people, but there are an order of magnitude more lightning strikes. Every year, around 350 million lightning bolts actually strike the ground. So then, just given these two numbers, what's the chance of your eye being hurt by lightning? Well, it'll be 240,000 divided by 350 million, or 0.07%. The point I'm trying to get across here is how to use basic probability. We took some observations, like the number of times a lightning struck a person, and the total number of times we observed lightning in a year to calculate this figure. Now, suppose we had to work out the chance of an email being spam. Any email, that is, right? Any email in the whole world. We can apply the same technique as in the lightning example. The chance of an email being spam should also depend on two things. Namely, 1, how many spam emails were sent, and 2, how many emails were sent in total. With these two quantities in hand, we can work it out. So I trawled the internet, and here's what I pulled up. In 2017, there were an estimated 148 billion spam emails sent. That's right, billion. And the total number of emails being sent was approximately 269 billion. So that means if a new email comes into your inbox, the probability of that email being spam or having been spam in 2017 was 55%. And this is simply based on the observation of the frequencies, namely the total number of spam emails divided by the total number of all email traffic. So you can think of calculating the basic probability as step 1. We figured out the overall probability of spam, but we can't build a classifier with this alone. So what's step 2?